In this lesson, we're going to learn how to balance chemical equations. We'll use the reaction of lead nitrate decomposing into lead oxide, nitrogen dioxide, and oxygen gas as an example. Let's first write down the chemical equation that we are trying to balance. Lead 2 nitrate decomposing into lead oxide, nitrogen dioxide, and oxygen gas. This type of reaction is a decomposition reaction where a single compound breaks down into two or more simpler substances. In a balanced chemical equation, we have the same number of each type of atom on both sides of the equation. You can think of each side of the equation as a scale, which means the number of each type of atom must be equal on both sides to keep it balanced. Let's go through and count the number of each type of atom on both sides of the equation. On the left-hand side, we have 1 lead atom, 2 nitrate ions, which gives us 2 nitrogen atoms and 6 oxygen atoms in total. On the right-hand side, we have 1 lead atom, 1 nitrogen atom from nitrogen dioxide, 2 oxygen atoms from lead oxide, 2 more oxygen atoms from nitrogen dioxide, and 2 from oxygen gas, so we need to adjust these to match. To balance the equation, we'll proceed with trial and error. Since the oxygen atoms appear in different compounds on the right-hand side, let's start with nitrogen and fix the nitrogen balance first. To balance nitrogen, we can put a coefficient of 2 in front of NO2. This gives us 2 NO2, balancing the nitrogen atoms. This also changes the oxygen count, helping us balance oxygen later. Now let's count again. On the left, we have 6 oxygen atoms. On the right, we now have 1 from PbO from 2 NO2 and 2 from O2, totaling 7. So we need to adjust our equation by changing the O2 coefficient to a half, making it 2 times 1/2, or 1O2, which finalizes the balance. So the balanced equation is, note that using fractional coefficients is acceptable in many contexts when it comes to reaction stoichiometry, but for certain specific applications such as physical chemistry, mathematics, or theoretical calculations, you may be expected to convert fractions to integers by multiplying all coefficients in the reaction by the same number. Here we wanted to keep it simple to demonstrate how balancing is achieved deeply. So remember,